Some engines make history for their power, reliability, or innovation, but others, they make headlines for all the wrong reasons. From oil-burning nightmares to timing chain catastrophes, these engines left drivers stranded, wallets empty, and mechanics shaking their heads. Whether it was bad design, poor execution, or just plain bad luck, these motors earned their spot on the wall of shame. Here are the 20 worst engines ever put in production vehicles. The Jaguar 512 engine, produced from 1971 to 1997, was a bold symbol of British luxury and performance. But under the hood, it was a ticking time bomb of complexity and overheating issues. Found in models like the XJ12 and the E-Type Series 3, this massive 5.3-liter and later 6.0-liter engine offered smooth power and refinement, but keeping it running was another story. The cooling system was infamously unreliable, especially in warm climates, leading to constant overheating that warped heads and fried gaskets. The engine bay was cramped and over-engineered, making even routine maintenance a labor-intensive ordeal. Vacuum lines, sensors, and electrical connections aged poorly and often failed without warning. Fuel injection systems were temperamental, and oil leaks were practically standard. To make matters worse, the V12 delivered poor fuel economy and required premium gas, adding insult to injury for frustrated owners. While the engine was admired for its ambition and smoothness, it became known more for shop time than drive time. The Jaguar 512 is now remembered as a beautifully flawed powerhouse, graceful on paper, but a headache in the real world. The Chrysler 2.2-liter turbo inline-4 of the 1980s was supposed to inject excitement into the brand's compact cars, but it ended up delivering more headaches than horsepower. Found in cars like the Dodge Daytona, Omni GLH, and Chrysler LeBaron, this engine was part of Chrysler's turbocharged push during the performance-starved 80s. While it produced decent power for its size, reliability was a major issue. The turbochargers were prone to failure, especially when drivers pushed the engine hard without proper cooldown, leading to oil coking and premature wear. The engine also suffered from poor heat management, causing cracked exhaust manifolds and frequent overheating. Oil leaks were common, and the head gaskets had a reputation for blowing under sustained boost. Adding to the frustration, the electronics and sensors controlling the turbo and fuel systems were notoriously unreliable. Power delivery was abrupt and laggy, making daily driving jerky and unpredictable. While the 2.2-liter turbo had potential on paper, in practice it became known for fragile components and inconsistent performance, a bold experiment that left many owners stranded on the side of the road. The Oldsmobile Quad 4 engine, produced from 1987 to 2002, was GM's attempt to build a modern high-performance four-cylinder, but it ended up being loud, rough, and notoriously unreliable. Found in cars like the Oldsmobile Cutlass Calais, Pontiac Grand Am, and even the Chevrolet Beretta, the Quad 4 looked great on paper with dual overhead cams and up to 180 horsepower. But in practice, it vibrated so violently that it required extra engine mounts just to stay in place. The harshness translated to a noisy, uncomfortable ride, and interior parts often rattled themselves loose. The timing chain system was complex and prone to failure, and head gasket issues became increasingly common as the engines aged. The water pump was buried in the engine and difficult to service, driving up repair costs. While GM later tried to refine the design, the damage to its reputation was already done. The Quad 4 became known as an overhyped, underdeveloped power plant. That made a lot of noise, both literally and in complaints, proving that performance specs mean nothing if the engine can't survive real-world driving. The Ford 3.8-liter Essex 5.6, used widely from the 1980s through the early 2000s in models like the Ford Taurus, Mustang, and Windstar, became infamous for one major problem: head gasket failure. Early versions of this engine were especially prone to blown gaskets due to poor design and weak materials, often causing coolant leaks, overheating, and eventually complete engine failure. Even under normal driving conditions, many owners experienced gasket failures before reaching 100,000 miles. Ford issued recalls and extended warranties, but for many, the damage was already done. The engine also suffered from balance issues that led to excessive vibration and premature wear on internal components. Intake manifold leaks and ignition coil failures added to the list of frustrations, turning what was supposed to be a reliable V6 into a constant source of repairs. While later versions were improved, the 3.8 liters early reputation stuck, and not in a good way. For drivers in the 90s, owning a car with this engine often meant surprise trips to the mechanic and a deepening distrust in Ford's engineering. The Mercedes-Benz M272 V6 engine, produced from 2004 to 2008, was intended to be a refined modern power plant for luxury vehicles like the E-Class, C-Class, and CLS, but it quickly gained a reputation for expensive failures that blindsided many owners. The most infamous flaw was the balance shaft gear, which wore out prematurely due to poor metallurgy. When it failed, it caused engine timing issues that triggered check engine lights, rough running, and eventually major internal damage. Repairing it meant removing the engine and replacing costly components, often running upwards of $4,000 to $6,000. On top of that, the engine suffered from timing chain tensioner issues, oil leaks from valve cover gaskets, and problems with the intake manifold swirl flaps. Even the thermostat and crankshaft position sensor were known to fail early. For a brand known for engineering excellence, the M272 left many owners with unexpected repair bills and a dented perception of German reliability. Despite offering smooth performance and decent power, this engine became a reminder that complexity without durability can turn a luxury car into a financial trap. The Toyota 3.0-liter V63VZE, produced from 1988 to 1995 and found in models like the Toyota Pickup, 4Runner, and T100, was built during a time when Toyota was earning a reputation for bulletproof reliability. But this engine didn't quite live up to the standard. The biggest issue was its head gaskets, which were prone to failure due to a factory defect that Toyota later acknowledged. These failures often led to coolant mixing with oil, overheating, and in some cases, complete engine breakdowns. The narrow engine bay in trucks and SUVs made repairs difficult and expensive, adding to owner frustration. The engine also had a restrictive intake and conservative tuning, resulting in sluggish performance and poor fuel economy for its size. While the 3VZE was durable in some respects, its poor efficiency and gasket problems made it one of the weaker links in Toyota's otherwise strong lineup. For drivers expecting classic Toyota dependability, this engine was a letdown, proof that even the most reliable automakers can occasionally miss the mark. The Renault 1.6-liter DCI diesel engine, widely used throughout the 2010s in vehicles like the Renault Megane, Dacia Duster, and Nissan Qashqai, was marketed as a modern, fuel-efficient diesel solution, but under the hood, it was a minefield of mechanical problems. One of the most serious flaws was the timing chain, which stretched prematurely and could fail without warning, leading to catastrophic engine damage. Turbocharger issues were also widespread, often caused by poor oil circulation or carbon buildup, resulting in sudden power loss and expensive repairs. The EGR system was another weak point, frequently clogging with soot and causing rough idling, reduced fuel economy, and increased emissions. In some cases, coolant leaks and oil contamination added to the list of headaches. Owners also reported inconsistent cold starts and a general lack of durability in long-term use. Despite being packed with efficiency tech, the 1.6 DCI proved too fragile for the real world. For many drivers, It turned the dream of low-cost diesel motoring into a cycle of breakdowns, warning lights, and mounting repair bills. The Saturn 1.9-liter SOHC engine, used widely throughout the 1990s in models like the Saturn SL and SC1, was designed to be simple, fuel-efficient, and budget-friendly, but it quickly gained a reputation for oil consumption and reliability issues. The biggest problem was excessive oil burning, often caused by poorly designed piston rings that allowed oil to slip past and burn off unnoticed. Many owners had to top off their oil between every fuel stop just to avoid engine damage. The SOHC variant was also known for cracking cylinder heads, especially around the camshaft journals, leading to coolant mixing with oil and eventual engine failure. Timing chain wear, noisy operation, and weak power output added to the list of complaints. While it was cheap to build and easy to work on, the engine often felt underpowered and rough, especially as it aged, for a car marketed as a practical choice. The Saturn 1.9-liter SOHC left many drivers frustrated. It may have been affordable up front, but over time, this engine proved that saving money initially doesn't always mean saving money in the long run. Let's open the hood on the GM 350 diesel V8, one of the most infamous engines of the late 1970s and early 1980s, rushed into production during the fuel crisis. GM didn't design a new diesel engine. They simply modified their existing 350 gasoline V8. That decision turned out to be a mechanical nightmare. The engine block wasn't reinforced to handle the high compression of diesel, leading to warped heads and blown head gaskets. Head bolts stretched under pressure, causing internal damage. Fuel injection systems were unreliable, and water often contaminated the diesel fuel, wrecking the injection pump. With just 120 horsepower, performance was sluggish at best. Cold starts were brutal. The engine clattered, smoked, and struggled under even modest loads. Reliability was so poor that many owners filed lawsuits, forcing GM to buy back vehicles. Mechanics hated it, parts failed constantly, and dealership service was inconsistent. It was underpowered, overcomplicated, and poorly supported. The GM 350 diesel V8 didn't just ruin cars, it damaged GM's reputation. It remains a cautionary tale of what happens when cost-cutting meets bad engineering. The Chrysler 2.7-liter V6, used from 1998 to 2010 in models like the Dodge Intrepid and Chrysler Sebring, earned a reputation as one of the most failure-prone engines of its time. While it was marketed as efficient and smooth, real-world performance told a different story. The engine was notorious for severe oil sludge buildup due to poor internal oil flow, narrow oil passages, and a weak PCV system. Even drivers who followed maintenance schedules to the letter often found their engines failing prematurely, sometimes before hitting 70,000 miles. Timing chain failures were another frequent issue, with stretched chains leading to poor performance or complete engine failure. Worse, the water pump was located inside the engine and prone to leaking coolant directly into the oil system, contaminating lubrication and causing rapid internal wear. These design flaws meant that many 2.7-liter engines simply couldn't survive long-term use. Expensive repairs, combined with poor reliability, turned what should have been practical family sedans into costly mistakes. The Chrysler 2.7-liter V6 is now remembered as a textbook case of how bad engineering can destroy brand trust. The Cadillac HT4100 V8, produced from 1982 to 1987, was Cadillac's ambitious attempt to embrace modern, fuel-efficient technology. But it backfired spectacularly. This engine featured an aluminum block with cast iron heads, a combination that caused constant head gasket failures due to differing expansion rates. The cooling system struggled to keep up, often leading to overheating and warped components. Early electronic fuel injection systems were unreliable, and sensors frequently failed, causing rough idling, poor acceleration, and hard starts. Internal components like camshafts and lifters wore out prematurely, and oil pressure issues were common, sometimes leading to complete engine failure. The engine also made a disappointing 135 horsepower, leaving drivers with neither power nor peace of mind. Mechanics dreaded working on it, and owners faced high repair bills that often exceeded the car's value. For a brand that built its name on luxury and reliability, the HT4100 was a public embarrassment. It damaged Cadillac's reputation for years and is still remembered as one of the most underwhelming and fragile engines ever put in a luxury car. The Ford 1.6-liter EcoBoost, introduced in the 2000s and 10s and used in popular models like the Escape, Fusion, and Fiesta ST, was designed to offer turbocharged performance with improved fuel efficiency, but it quickly became known for serious reliability problems.
6-liter EcoBoost sounds has lots of clacking sounds, and it also has a hum noise.
The most alarming issue was coolant intrusion into the engine's cylinders due to a flawed cylinder head design. This caused overheating, engine misfires, and in many cases, complete engine failure. Some vehicles even caught fire, prompting multiple recalls and lawsuits. The turbocharger itself was another weak point, suffering from early wear and oil starvation that led to costly repairs. Timing belt maintenance was also tricky, as it was oil immersed and required strict replacement intervals, often neglected by owners unaware of the risk. Many drivers reported stalling, rough idling, and unexplained power loss, all stemming from a combination of engineering shortcuts and poor thermal management. Despite Ford's updates over the years, the damage was done. The 1.6-liter EcoBoost became a warning to consumers. Just because an engine promises modern performance doesn't mean it won't leave you stranded and smoking on the side of the road. The Subaru 2.5-liter EJ25, produced between 1996 and 2011, is one of the most well-known engines in the brand's lineup. And unfortunately, also one of the most problematic, found in popular models like the Outback, Forester, and Legacy. The EJ25 earned a notorious reputation for persistent head gasket failures. Early versions of the engine suffered from internal leaks, allowing coolant and oil to mix or escape, leading to overheating and eventual engine damage. Even updated gaskets didn't fully solve the issue, and many owners found themselves replacing head gaskets more than once. On top of that, the engine was prone to piston slap, excessive oil consumption, and carbon buildup, particularly in turbocharged variants. While Subaru fans praised the Boxer engine's low center of gravity and smooth performance, the long-term reliability just wasn't there. Many vehicles with this engine became costly to maintain once out of warranty, turning loyal customers into frustrated ones. Despite its balanced design and capable performance, the EJ25 became a textbook example.
Basically, the noise comes from everywhere, pretty much,
of how repeated design flaws can overshadow engineering benefits and push buyers toward other brands. The BMW N54 twin-turbo inline-six, produced from 2006 to 2016, was praised for its smooth power delivery and impressive performance, but it quickly earned a reputation for being one of BMW's most high-maintenance engines.
So this is what a defective alternator pulley sounds like.
Found in vehicles like the 335i, 135i, and early versions of the 740i, the N54 suffered from a long list of issues that made ownership expensive and frustrating. High-pressure fuel pump failures were so common, they triggered a recall and multiple warranty extensions. The twin turbos, while responsive, were prone to wastegate rattle and eventual failure, often requiring costly replacement. Carbon buildup on intake valves plagued the direct injection system, causing rough idling and reduced power. Leaking valve cover gaskets and oil filter housing gaskets were practically expected, and injectors often failed without warning. While the engine could be tuned for incredible performance, reliability took a backseat. Even fans who loved the power and tuning potential admitted that maintenance costs were brutal. The N54 is now remembered as a brilliant but deeply flawed engine, a mechanical thrill ride with a repair bill that never stopped climbing. The Mazda rotary 13B engine, especially in the RX-8 from 2003 to 2012, is one of the most unique and misunderstood engines ever put into a production car, and also one of the most problematic. While its high-revving nature and lightweight design made it a blast to drive, the 13B was plagued with reliability issues that turned many owners away from rotary technology for good. The biggest problem? Apex seals. These critical components wore out quickly, especially under aggressive driving or poor maintenance, leading to compression loss and engine failure. The engine also consumed oil by design, but many owners didn't realize it needed frequent top-offs, causing premature damage. Cold starts were difficult, fuel economy was abysmal, and emissions problems were common. Flooding issues after short trips made the engine notoriously hard to restart. Even when running well, it required constant attention. Despite its innovation and cult following, the RX-8's 13B engine became a cautionary tale. One that proved being different doesn't always mean better, especially when reliability is sacrificed in the name of engineering novelty. The Ford 4.2-liter Essex V6, used from 1997 to 2008 in vehicles like the Ford F-150 and Econoline vans.
Hello and welcome to my channel. Well, I'm gonna ask you guys,
was supposed to be a dependable workhorse, but it quickly earned a reputation as one of Ford's most failure-prone engines. Based on the older 3.8-liter V6, the 4.2-liter suffered from serious design flaws that led to catastrophic issues, the worst being the intake manifold gasket and timing cover failure. These leaks often allowed coolant to enter the crankcase, resulting in diluted oil, worn bearings, and complete engine failure. Many trucks with this engine experienced sudden breakdowns, sometimes with no warning. The head gaskets weren't much better, carrying over the same weaknesses from the 3.8-liter. Adding to the frustration, the engine lacked the torque expected from a truck motor, making it feel underpowered even when it wasn't overheating. For a vehicle marketed toward hard-working drivers, the 4.2-liter Essex V6 proved to be unreliable, costly to repair, and underwhelming in performance. It stands today as a reminder that scaling up a flawed design doesn't fix the problem, it only makes it worse. The Volkswagen 1.8T engine from the early 2000s, found in models like the Jetta, Passat, and Audi A4, was a turbocharged four-cylinder that promised sporty performance and decent fuel economy. But for many owners, it turned into a maintenance nightmare. The biggest issue was oil sludge buildup, caused by narrow oil passages, long service intervals, and a small oil capacity. Even with regular oil changes, sludge could clog vital components, leading to oil starvation and eventual engine failure. The turbocharger itself was prone to premature wear, especially if the engine wasn't properly cooled down after hard driving. Coil packs failed frequently, causing misfires and check engine lights, while the timing belt had to be changed religiously or risk catastrophic damage. Vacuum leaks, PCV issues, and finicky sensors were also common, making this engine feel more high maintenance than high performance. While the 1.8T was quick and fun when running properly, many drivers were blindsided by the constant upkeep and expensive repairs. It's now remembered as an engine that offered European flair at the cost of your savings account and sanity. The Chevy Vega's 2.3-liter aluminum inline-4, produced from 1971 to 1977, is one of the most infamous engines General Motors ever built. Designed with an ambitious all-aluminum block and no iron cylinder liners, the engine was meant to be lightweight and fuel efficient. Instead, it became a mechanical disaster. The soft aluminum wore quickly, leading to scoring and loss of compression. Overheating was a constant issue, made worse by a poorly designed cooling system and a warped head prone to failure. Early versions didn't even have proper corrosion protection, so coolant would literally eat away at the engine from the inside. Oil consumption was excessive, and leaks developed early. Even basic reliability was questionable, with many engines needing a rebuild before 60,000 miles. The Vega's engine quickly earned a reputation for failure, damaging both the car's reputation and GM's credibility. What was meant to be a symbol of modern engineering turned into a cautionary tale.
5,000 miles and a misfire. Let's see.
The 2.3-liter Vega engine didn't just overheat, it torched consumer trust and became a case study in overpromising and under-delivering. The Ford 5.4-liter Triton Phi 8, used from 1997 to 2010 in popular vehicles like the F-150, Expedition, and Lincoln Navigator, promised strong performance and towing capability, but it's now better known for spark plug nightmares and costly repairs. One of the most notorious issues was the tendency for spark plugs to either seize in the aluminum heads or, worse, blow out entirely while driving, ripping threads with them. Repairing this often meant expensive machining or head replacements. Early versions also suffered from timing chain tensioner failures and cam phaser problems, leading to loud knocking noises, poor performance, and stretched timing chains. Oil leaks from valve covers and intake manifold gaskets were common, and the overall maintenance cost piled up quickly. Despite offering solid power on paper, the engine's weak points turned basic tune-ups into anxiety-inducing jobs. For many Ford truck owners, the 5.4-liter Triton became synonymous with unreliable maintenance and unexpected breakdowns. It remains a frustrating chapter in Ford's V8 history, capable when it worked, but often just one spark plug away from disaster. The Peugeot Renault 5.6, commonly known as the PRV engine, was produced from the 1970s through the 1990s and found its way into a wide range of vehicles, from the DeLorean DMC-12 to Volvo sedans and French executive cars. While it looked promising as a joint venture between three major automakers, Peugeot, Renault, and Volvo, the execution left much to be desired. Early versions were rough, unrefined, and lacked balance, largely due to their odd fire configuration, which made them sound harsh and run unevenly. The engine was underpowered for its displacement, often delivering lackluster acceleration and poor fuel economy. Oil leaks, premature wear, and timing chain issues were common, especially as the engine aged. Cooling problems also plagued certain applications, leading to overheating and cracked heads. Despite being used in high-profile models, the PRV engine never lived up to the expectations of a world-class V6. It became known more for its quirks and limitations than its performance. For many drivers, the PRV was proof that just because multiple companies design an engine together doesn't mean it will end up being good.